So let's look a little more about these geometric sequences. That first one we had, if we were to graph that, so say you have 1, 2, 3, 4, 5, 6, something like that. And then we're going to have to count these fairly big. So let's go 10, 20, 30, 40, 50, 60, 70. Oh, probably going to have to go bigger than that. Let's go fit by 50s. So 50, 100, then we'll go 200, 300. We'll have to go a little bit higher. 350, 4, 5, 450, 5, 556. Okay, so 600 would be way up there. Okay, but that's fine. So if n is 1, so if this is my n, and then my output is 5, so it's not very high up. And then if n is 2, it's going up. Oh, n was 1, it's even lower. And then it went to 5, so not very big. 25 is about halfway up, 3. Now I'm on the fourth term, so 125. So it's about there, I'll say. And then 625, that's going to be way up here. So you see you have these points and you see what it looks like. We've seen exponential functions before. Now, it looks like this function here, although they're individual points, like we talked about in the other sequences that we graphed. Notice that we have x minus 1. That has to do with, because we're starting at the first term where x is 1. The domain here is counting the natural numbers, okay? Natural numbers, oops. So 1, 2, 3, and so on. We talked about that, how you have a first term, a second term, a third term, so on and so forth. Okay. All right, so that's just a little bit about the graph and what it looks like. You can see these individual points here on the graph because we're not having in the domain all real numbers, they're just the natural numbers. So here's an example that says write the first 6 terms of the geometric sequence with first term 6. Okay, so they tell me a sub 1 is 6, and then, oh, I have to do 6 terms. Okay, so let's see. I'll go down the page here. So a sub 2, okay, so the first term is 6. The common ratio is 1/3. So to get to the next term, I'm going to be multiplying by 1/3. So I'm going to say take 6 times 1/3, which is going to give me 2. Okay, so you can think about that and how you get 2. Then the next term is going to be 2 times 1/3. So we keep multiplying by that ratio. So I get 2/3. The next term is going to be 2/3 times 1/3. So every time I'm multiplying by that common ratio. So I'm going to get 2/9. And I'm supposed to do 6 terms, right? So the fifth term, 2/9 times 1/3, which is going to be 2/27. And then my last term, it's going to be 2/27 times 1/3, which is going to give me 2/81. So you can check out that multiplying and stuff, but that's what we get. So for the first 6 terms, I'm getting 6, then 2, then 2/3, 2/9, 2/27, and then 2/81. Those would be the first 6 terms. Okay?